Okay, welcome back, ladies and gentlemen. In this video, we're gonna assemble a slider crank linkage. This is going to be our case study just to show you how an actual assembly is put together, and then we're gonna do kinematic and dynamic analysis. So it's gonna serve as a kind of a closeout, just a example to show you how assemblies work. So you should do this just to kind of reinforce what you learned in the previous videos, and then it's going to be a slight transition into the next set of videos, which is going to be concentrated on kinematic dynamic analysis on mechanisms, where we're going to make mechanisms and we're going to analyze them, and after that maybe we'll get into some FEA. But I'm thinking ahead too much, but let's look at this. These are the parts that I've made, and I'm gonna compare them side by side to this linkage. So let's look at this linkage first. We have a pin around which we have this link that's rotating. That link is connected to this driven link, this long one, and it's connected through a pin inside of it right there. And then we have a slider that's constrained by a sliding path, and the rotation of this is attached, this driven link is attached to the slider, and rotation of this link is causing this motion of sliding back and forth. And one of the most common applications for this is a piston in a car engine. If you understand how engines work, or even if you've just seen an engine, you always hear people talking about 8-cylinder, 4-cylinder, 6-cylinder. They're talking about essentially the pistons, and that's one application. We could analyze it and just see how it is. They're more like actually trains. I think trains had them. I'm not sure actually. Let's just begin. So these are the parts that I've made right here. This is a stand, which is essentially the main pin right here, around which we have our link rotating. Just terminology right off the bat, we have this driving link, and then we have the driven link. That's what I'm gonna call it. And this is the pin for the driving link. The driving link is gonna rotate around this pin. Then we have the driving link itself, which is a small link right here. Then we have the driven link, which is a lengthy one. Then I got a pin that's gonna connect both of them. Then I have a slider. This is the brick. This is the yellow brick in the animation right here that I made. It's essentially a brick with the cylinder on it. You should be able to make that in Creo. And then we have a path for the brick to slide in, and that's what this is gonna serve as. It's a very simple part. Again, just make this shape and extrude it outwards. Not very complicated at all. Just make sure you dimension things properly. Make sure the path, so this distance right here, when you make this shape, this distance, this gap, should be the same as the width of this brick right here. So just make sure it makes sense physically, and just like that, the pin, the diameter for this pin is the same as the diameter in these holes for the links. Things like that. They're pretty straightforward. Just want to mention them anyway. I'm gonna go to the default view right here, and I'm gonna begin. So I already have this subassembly made. And in this subassembly, I'm gonna make a slider component of this main assembly right here. So I guess I should explain. We can divide this up into two different subassemblies. We have this yellow brick that's sliding back and forth in this path, and then we have these two links that are attached to this brick. So we can assemble them separately from one another and bring it together in one main assembly. That's what we're gonna do, and I want to do that because I want to reinforce the idea of using subassemblies, and just kind of show you that it's easier to manage subassemblies than it is to manage just one giant assembly of 1,500 different parts. It's just easier to make changes that way, and it's just the preferred way for me, I guess. And I definitely recommend that you do it the same way. So let's bring in our main slider, our slider path right here. So if you remember from the second video, we want at least one part in our assemblies that doesn't move in any way. So all these degrees of freedom should be taken away, and I'm going to do that by selecting default. I'm gonna click default, and it's gonna fully constrain it, and I'm gonna hit OK. Now if I do drag components and I try to drag it, nothing should happen, and as you can see, nothing's happening. We want that. That's good practice, and that's what we're gonna do. Now in this, I'm gonna constrain a brick, and I'm gonna use a slider connection for it. I'm gonna bring in the brick, and you're gonna get to a point once you keep using Creo often enough where you're gonna know exactly which set of constraints you need to make for any particular connection. So when I select slider connection here, I already know it's gonna ask me to align the axes, and you don't need to go into placement every time. You can see it on the bottom left corner right here. It's already giving me the prompt to select axes or edges that are gonna align, and it's gonna tell Creo that this is the direction in which we want the part to slide. So I'm gonna select this edge right here. Let me get rid of these datum planes, and I'm gonna select this edge. Once I select that edge, I'm gonna select another edge from the main assembly, from the path, and look at that. It immediately places that brick right next to those two straight edges, because now we define the path in which we're allowed to go back and forth. But we still have another degree of freedom. We still have this rotational degree of freedom, which we don't want, because physically this makes no sense. We can't have bricks going into parts like that. So we'll constrain it. We'll constrain the surfaces. We'll just select these two, and that happened to be, that didn't happen to be, that exactly is the next constraint. It's asking us to constrain the rotation, which is what we did. And once you keep using these kind of connections, you're gonna get to a point where you're gonna know it, and you're just gonna do this whole thing in 2 seconds. I'm just going over it just to kind of show you, but eventually I'm gonna just do things without explanation, and I kind of expect you to know what it means, because we have used it often enough. And now I'm gonna hit OK. So now it's allowed to slide back and forth, and the way I'm doing that again is I'm pressing Control Alt, I'm pressing and holding Control Alt, and then I'm left clicking and dragging the component that I want to move, and that's how I can do this. Now I could have gone further, and I could have constrained this slider connection by giving it a maximum and minimum distance, but I'm not going to do that, because that happens automatically. If we look at this linkage again, the movement of this yellow brick is not limited by anything here. It's limited by this small link, because the small link can only go a certain distance, which is its own length to the right, and it can only go a certain distance, which again it's its own length to the left. So the maximum distance this is going to be displaced back and forth is 2 times the length of the small link. So we already know this. This is how it's going to be constrained. We don't really need to do it ourselves, and we're going to leave it like this. So I'm going to save this. I'm going to hit save. Always save your work. Oh, didn't regenerate. Let me just regenerate. You can hit the regenerate button, or you can press Control G on your keyboards, or I think I don't know what it is on Mac. I'm not gonna even try to guess, but Control G and you should be able to regenerate. Then save it, and then close it. You can close it by hitting this file button right here, because what that allows you to do is, again, stay within the Creo environment, and it allows you to close the window for the assembly. And now we're gonna make a new assembly. I'm sorry, I'm trying to open it. So we're gonna make a new assembly, and I'm gonna call this the main assembly. Now the reason I'm not making another sub-assembly is because once we assemble the linkage, we can just bring in our slider sub-assembly and just put it together right there. So we don't need to make 3 assembly files. We just need to make 1 sub-assembly, 1 main assembly, but we're still putting together 2 separate sub-assemblies, but we're gonna have 1 main. I guess I kind of confused you there with the wording, but you'll see what it means. I'm gonna call it 00 again, because I like to have my sub-assemblies ahead of everything. I'm gonna call this main assembly. Okay. I'm gonna open up the datum planes. I'm gonna start this. If we look at this again, we can make this main pin around which this driving link is rotating. We can make that our default. We can make that our part that doesn't move. So I'm gonna do that. I'm gonna bring in this. I'm calling it a stand. It's not really a stand. I'm gonna say it's default, and that's that. So this is the pin around which our driving link is going to rotate. I'm gonna bring in link 1, and you should already know that this is gonna be a pin connection right here. I'm gonna select the pin connection, and again it's asking me for axes around which we want it to rotate. I already know this. I'm not gonna go into placement every time, and then obviously it's gonna ask me to limit this degree of freedom right here, because if you look at the degrees of freedom we have now, we're allowed to rotate, which is what we want, but then it's also able to slide. We don't want that. And in a pin connection, it's always going to ask us to limit that linear back and forth after the axis alignment. I already know this, so I'm going to select this. You could go to placement and do translation, but I'm not going to keep doing that. And that's it. I'm going to hit OK. And now I should be able to move this, and I can. Look at this. It's going well, but I'm gonna change the appearance now, just to kind of differentiate between the two. Even though we only have 2 components, it's just good practice to color your components differently, and just have them look nicer. That's not too different. That's not different at all. Actually, we're gonna make it gold because I'm feeling like Iron Man today, and I'm gonna make the other components red. Okay. So let me bring in the smaller pin that's going to connect the bigger link. This is our pin. Again, the pin's going to have a pin connection. That's kind of a redundancy there, but alright. So I'm going to align the axes, and now I'm going to align the 2 surfaces. And that's that. It's a pin connection. Actually, let me select the pin connection. Okay, so don't make this mistake, because you might jump the gun like I just did, and without selecting pin connection you just start making constraints. Don't do that, because it's gonna lead to some problems. I'm gonna do the same thing again, and there we go. So we have our pin connection, and then we have our pin connection right here. So the way to confirm that your part's kind of moving right here is you can kind of just drag it and rotate and see how I'm allowed to kind of move this back and forth. It's because there's a pin connection. If you track, or if you just notice the blue little marker right there, that's indicating how I'm allowed to move, and if I'm allowed to move at all. So see right here how it moves with it. Same thing's happening right here. It's moving with the rotation, and that's how I know it's allowed to move. So I'm gonna regenerate it now. Now we can assemble in our larger link, but we need to kind of plan this ahead. And the way it's gonna come together is, if we make this larger link now and then we bring in our sub-assembly, we can't, or we won't be able to constrain this large link to the slider assembly. And let me just do that. So I'm gonna mess up on purpose right here, just to kind of make a point. Let me assemble this large link, and I'm gonna make a pin connection again. I'm gonna select pin, and I'm gonna select the axes, select the 2 surfaces that remain in line, hit check. So this is how we want it to work. This is good. This is dandy. Now I'm gonna bring in the sub-assembly that we made. I'm gonna say bring in the slider sub-assembly, and then I'm gonna place it using the distance constraint. Now here is where you use the physical location constraints right here. Remember from the previous videos, this is the behavior constraints, and these are the physical location constraints. And if I'm trying to place a sub-assembly, I'm only going to be using these physical location constraints. I'm not going to try to use any of this. Unless it applies, then definitely go ahead and use it. But right now I'm just trying to place it a certain distance away from the main link. If you look at this right here, we have this pin, and it's a certain distance away. That's all we need to do. So I'm gonna do that, and I can use datum planes to do this. I'm gonna say it's a distance constraint, and I'm gonna say this vertical plane for the pin is a certain distance away from this vertical plane of this subassembly. And it already gave me a value of how far it is now, and I'm gonna say it's, let's say, 10. Just bring it in a little closer, and we still have quite a few degrees of freedom. It's still allowed to rotate like this. It's still allowed to go back and forth, up and down, and we don't want that. So we're gonna limit some more things. And before I actually do anything, let me just make another point. Whenever you're trying to constrain sub-assemblies that you bring in, make sure that you don't constrain moving parts with static components. What I mean is, if you look at this sub-assembly, we made it so that we can slide this brick back and forth. But if we constrain it to a part, or let's say if I use the surface of this sliding component to constrain, and I use the static component, and then I hit OK, watch, it's not gonna allow me to rotate, or it's not gonna allow me to move the slider anymore. Or it is. Huh, let me just regenerate this. Interesting. Edit definition. Component coincident. Oh, it's still okay. Let me properly constrain this again. So I use the surface for this, and that. Now I need to do another one where I do a static vertical. I'm sorry. Let me open up datums. Let me make the vertical planes coincident. Okay, that's fine. I think that's fully constrained now. Or is it? It's still not physically fully constrained. Huh. It should be though. Hold on a second. Edit definition. What kind of constraints do I already have? I have a distance constraint. Then let me get rid of this for now. I'll show what that exactly implies. But let me just make the horizontal planes coincident. And then I'm going to use that surface constraint that I was talking about before. So again, remember, this is the slider brick that's allowed to move back and forth, and I'm going to use that surface to try to constrain horizontal displacement. That's done, and now I'm gonna make a new constraint, even though I don't really need it, and I'm gonna delete it immediately. But I guess this kind of highlights how Creo can be kind of silly sometimes. So let's do this. I'm gonna do that. I'm gonna get rid of it. Okay. And okay. Interesting. That's fine. That's fine. That's fine. It should be fully constrained now. There are 3 constraints limiting all 3 directions. Okay, so I'm back, and I'm gonna try to show you exactly and kind of make the point how Creo can be frustrating sometimes. So if you look at this, I still have the same exact constraints, and right here now I'm fully constrained. Let's watch again, and let's go through our constraints. I have this distance constraint that I made already between the 2 planes. That's fine. Then I have this horizontal plane constraint that I made already, and it's fine. Then I made the constraint between the 2 moving surfaces, and now it's fully constrained. If you roll back the video and if you look at this, and I did the same 3 exact things, and it said partially constrained. So this is kind of a point I want to make to kind of just get across that, you know, things like this are gonna happen in Creo, and don't let that just fool you. Sometimes you're doing the right thing and Creo's just deciding to be silly, and that's okay. And I'm gonna hit OK now. And if it's making any sense, they shouldn't be able to move. And okay, so right here. So let's examine this again. I'm gonna get rid of this coincident constraint right here. I'm gonna remove this, and when I hit OK, the brick is allowed to slide back and forth. Of course, it's allowed to move linearly as well. But the point I'm trying to make is when you go to edit definition again and make the constraint using a moving surface with a static surface, again it's gonna say partial constraint. Let me make a silly constraint again. Invalid constraint. I'm gonna remove it, and look at that, it says fully constrained. So I had to make a fictitious constraint that didn't make any sense then remove that constraint to for Creo to realize that it's fully constrained now. So that's what happens in Creo. It's okay. Silly things like that happen, but watch, it's not allowed to move. So let's do it right this time, and instead of using the moving surface of this constraint, I'm gonna use the static surface of this path, because the path is not allowed to move. It shouldn't move, and I'm gonna try to distance it properly. I'm gonna look at it from the left side, so I'm looking at it from the left. If that isn't clear, I'm gonna zoom in right here, and we want this shaft right here, this shaft end, to align with this end right here. So we'll say it's a distance constraint instead of a coincident constraint. So let's do maybe -2. Okay, I think that's fine. That's enough for me to properly constrain this, and I'm gonna say okay. Now the slider should be allowed to move back and forth because we used a static part, and look at that, it is allowed to move back and forth. And now here's what I was attempting to say when I said, wow, that's terrible English. So if you remember, if you roll back in the video, roll back, I don't know if that's a term, but if you rewind back and see that I was trying to say that if you bring in this link before this subassembly, you're gonna run into problems, and this is the problem that you're gonna run into. Now if I try to modify this link and try to make a pin connection with this slider, we're gonna have some problems. Let's say edit definition, and look at that, the subassembly disappears, and there's a good reason for that, and the reason is obviously because we have this model tree right here, and there's a hierarchy, and the thing is, it's only gonna allow me to modify this link with respect to the things that I've already made before it, not after it. So I can only modify things that come in before. So I can modify this, but it's a subassembly. I don't really want to mess around with these linkages right here. I could try to edit definition and do things with it, but now see, it suppresses the main assembly because I can't modify these connections and try to make connections with suppressed objects. So that's why we need to kind of get rid of this large link right here. I'm gonna hit delete and OK, and then I'm gonna bring it in later. So now when I bring it in and I hit OK, I haven't made any constraints yet, I know, but now if you look at this tree right here, I have the link after the subassembly. So if you do this, it allows you to actually interact with anything that's before it. So just keep in mind and kind of try to plan ahead and see which components might have multiple connections that need to be made, and make sure you have those components assembled last so you can make those multiple connections and constraints. So let me edit this, and let me place some pin connections. So I'm going to do the same thing as I did before. I'm going to put a pin connection with this right here, and then I'm going to have this surfaces as coincident. Now I'm going to make another connection. Now here's another thing. I guess here's something new. We made one pin connection, but we can make multiple pin connections. I'm going to say new set, and then I'm going to select these surfaces again with the pin connection already selected right here. I'm going to say here, and then I'm going to say those two surfaces. So I selected the axis alignment again, and I selected the translation. But I want you to notice that instead of coincident, when I selected the two surfaces, it automatically applied a distance constraint. Because if you remember from our left view, we left over a little bit of distance above the link, or I guess further than the link. So it already knows that it's a distance away, it's not a coincident constraint. And we're going to hit OK. And now when I click and drag these components, it should essentially behave like this. But let's look at it. Moment of truth. And it does. It's always satisfying to see your assembly work. It's very fun, and it's working now. Let me just color this red, because as I said, Iron Man's kind of like a red maroon thing going on, right? So we'll do this. It's an Iron Man color, and then we'll do white for that. I think it's white. Whatever it is, it's fine. So now we're gonna do. Actually, I'm gonna stop the video right here, and in the next video, I'm gonna do the kinematic and dynamic analysis. I don't know how long it's running right now, but yeah, I'm gonna stop this video right here. Sorry it got a little confusing with the constraints there when I tried to show you some mistakes that you can make. But hopefully it's clear that sometimes you're gonna do exactly the right thing and Creo's just not gonna know it. And I want you to know it's okay, that happens, and just keep trying. But let's move on to the next video now.